Okay, so today's notes are going to be a little bit different. I'm not doing them with the class because of how much stuff there is to write, and I'm not using the smartboard a lot during class. But for the notes, we'll go ahead and go through this on the smartboard. So what our goal is today, we're talking about determinants and Cramer's rule. All we're going to talk about today is the determinants part. It's a very long lesson, so we're just going to focus on determinants for right now. So all we're going to be able to do is evaluate determinants in a 2x2 and a 3x3 matrix. So if we go on to this next part, we have talking about determinants here. Determinants sound like the word determine, and they will come into play when we talk about Cramer's rule, when we get into that part of the lesson. For right now, we're just going to learn how to find them, and we'll worry about what exactly they mean later when we have understood how to find them, and we can understand how to find them using Cramer's rule for different equations. So we can have a couple of different kinds of determinants. The first kind we can have is a second order determinant, which is a 2x2 matrix. Determinants are only found for square matrices, and you'll understand why whenever we get into how to figure them out. We write it, we say the matrix A, B, C, D, and then we have this weird little thing that says the determinant is this. Those bars next to it, those are not absolute value bars, those are just determinant symbol bars. So those are not necessarily telling you that you are going to only have a positive number, those are just telling you that you are finding a determinant. Then what we're doing is we're finding AD minus BC, so we're starting to use this thing called the diagonal rule, which will come into play in our third orders. But all you do is you just start from the upper left hand and you go down and you multiply those together, which is this part right here. And then you come up here and you multiply those together, which gives you that part right there. And then you just subtract those numbers. So the second order determinant is fairly simple to find, so we won't worry about doing an example of one of those right now just because it's pretty simple to find. The other type of determinant we can have is what's called a third order determinant. We call it a third order because we have a 3x3. I will not give you guys one that is bigger than a 3x3 because I think that that would just be absolute torture. So you will only have 3x3 matrices when you are finding third order determinants, and you'll understand why as we go through this one. Those red steps right here, these are all of the steps that we use to find a third order determinant. So there's a lot of steps because we have to use the diagonal rule. Let's say we went through and I just wanted to do it just like I did a second order, and I started from here and I went down like that, here and here. Well, I have a problem because I'm not using all of my numbers just like I did here. So I need to figure out another way to do that, and that's when the diagonal rule comes into play. So the only difference between this and what the book says is that I switched a couple steps around, and I will tell you what those steps are when we get to them. But basically these steps are exactly the steps from the book. I think I almost exactly got them from the book. I might have changed a couple words, but they're basically exactly the same. What you're going to do is you're going to write the problem down again. So this is telling me I want a determinant because I have this line, so I have a determinant of a matrix. What we're going to do is we're going to evaluate using diagonals just like we did here, using the diagonal rule. So what we do is we start on step 1, which is rewrite the first 2 columns to the right of the determinant. So we come over here and we write 4 and 5, 1 and 3, 2 and negative 3. Now what we do is we go to step 2, which is draw a diagonal starting with the upper left-hand element. So now I'll go through and draw some diagonals. So now I can start at 4, go through 3 and 6, start at 5, go 0 to 2, negative 2, 1 to negative 3, and you just stop once you hit that determinant. Notice how I have these 3 numbers right here, 1, 2, and negative 3, that are also being used here. So I am using all of my numbers just like I was in the second order. So now, since I have used all of my numbers, I'm going to keep going, and it says multiply the elements in each diagonal. So we're going to multiply. So we'll go through and we'll say 4 times 3 is 12, times 6 is 72, and I'll just write it there. And then 5 times 0 times 2 is 0, and negative 2 times 1 times negative 3 is just 6. Then this is where I swapped the steps. So in the book, they have you do step 4 before step 3. I don't like that because I think we should figure out what the sum is. We should do everything before we move on to this step. So we're going to go ahead and find the sum of those products. So 72 plus 0 is 72. 72 plus 6 gets me 78. So I am now halfway done with the determinant. Now you can either rewrite this or you can just use different colors or keep track of where you are. Now we're going to move on to step 4 where it says repeat, but instead we're going to start with the upper right hand element. You can do that, but I like to think of starting from the lower left hand because then I stop when my determinant stops. So I'll just draw another diagonal through these and then do the same thing and find the sum. So 2 times 3 is 6, times negative 2 is negative 12. Negative 3 times 0, we'll just get 0 for that one. 6 times 1 times 5 is 30. And then we still do the same steps, so we'll add those. Negative 12 plus 30 is 18. Now, just like up here when we had AD minus BC, same idea. In this case, this is like, this right here is like our AD, so this is like our AD, and this is like our BC. So we will take AD, which is 78, and subtract BC, and get 60. So that's a little bit different than when we just do any of our other operations with matrices, because normally we get a matrix. In this case, you are doing a lot of work for a simple number, and that number will make more sense tomorrow if you're in class, and then tomorrow in the notes that I will post. So the next part, we'll go ahead and ignore this portion. We'll talk about that tomorrow. Now we can go through and evaluate these determinants. So if we go through this first one, since I have a 2 by 2, this will be a second order. So I can say this is A, B, C, and D. I can do 6 times 7 minus 5 times negative 2. Using my formula, just 42 minus negative 10, which is the same thing as 42 plus 10, so you could ignore that. I'll erase that. So we could just think of 42 plus 10, which gets us 52, so we found our second order determinant. If you are taking notes, pay attention to this next one in your notes. If I evaluate this one, I also have a second order, so I will have 3 times 6 minus 9 times 2, which gets me 0. Like I said, if you're taking notes, pay attention to this one and star this one, because this is incredibly important, and we'll talk about this and come back to it tomorrow when we do Kramer's rule. So we'll focus on that tomorrow. And we'll just go ahead and do number 3, because that's about as far as we went in every class, so we will go through number 3, and I might go through 22 as well, just to do another example for those of you who might be a little lost and are watching this video because you did not understand the notes in class. So same idea here, third order, so I'm going to start with my first step. 3 times negative 2, 0 times, or 3 and negative 2, 0 and 4, not times, and negative 1 and 4. And then I'll go through and evaluate using diagonals. So I go through this. Oops, I did it the wrong way. Just kidding, ignore that. I went the wrong direction first. Starting up here, going down like that. Honestly, if you did the lower part first, it wouldn't matter as long as you put that second, because order matters when you're subtracting, so just make sure you double check that. So we have 3 times 4 is 12, times negative 3 is negative 36. Negative 2 times negative 1 is 2, and then we have 0 here. And if we do the same thing, go in the other direction, what I was doing before, we get 0, 12, and 8. And now if we go through and we add those, so I'll get negative 34 here, and 20 up here, Now I'll just follow the same formula that I had, so negative 34 minus 20. Negative 34 minus 20, and that gets me negative 54. So notice that we can have a negative determinant. Whether it's positive or negative will come into play tomorrow. I know I keep saying that, but this is a 2-day lesson. If we could do it all in one day, we could, but even if we weren't taking a quiz today, we would not probably be able to do it all in one day. So we can just think about that, and then just for practice sake, we'll go ahead and do the next one as well. So 2 and negative 1, 3, 2, 2, 3. I'm finding a third order. Start from here and go down, here and go down, here and go down. 2 times 2 is 4, negative 5, negative 10. 3 times 3 is 9, 6 times 9 is 54. We'll add those together, so we'll get negative 6 here, and then 54 minus 6 gets us 48. And then the same idea over here. Go in the other direction now. Notice how I am using all of my numbers. So 2 times 2 is 4, 4 times 6 is 24, 3 times 5 is 15, and so I'll get 30 here. 3 times negative 1 is negative 3, so I would get 54 through here, which gets me 51. Then I take my first one, 48, subtract my second one, 51, and I will get negative 3. So that's just another one if you wanted practice. Since the homework is a little weird, it will be posted, but if we go to the very end, you can look at all of these tonight, but don't worry about 17 and 49 for right now, because we will talk about those. I didn't get to those ones in class, so I won't get to them on the notes either, because there's a formula for those. So you can look at the other ones and work on those. In class we talked about how this isn't due until Tuesday. That'll also be on the calendar in case you forget, not due until Tuesday. You will have 9 more problems with Kramer's rule that goes along with this homework, so make sure you do set aside enough time to work on it, because Kramer's rule can take a really long time. For those of you who weren't in class and maybe don't know or have some questions about matrix multiplication, we can look at a couple of the ones that we talked about. So make sure that you are doing the homework that I give you in class. If there is a different homework, I will tell you, so always go to the calendar, do the homework that is on the calendar unless told otherwise. So if you're in any class other than first hour, you should have these ones done. I noticed there were some questions in class about some of these, so in case you are wondering, let's say I have one matrix that's 1 by 2 and another matrix that's 2 by 1. These numbers right here in the middle, this is my column right here, this is my row. This tells me that I can multiply, so if they're the same, then I can multiply those matrices. These numbers out here, rows here, columns here, this tells me how big my matrix is. So it'll tell me dimensions of my answer. So in the case of 21, make sure you look at that one, because it is only one number, because it is a 1 by 2, I think it's a 1 by 2 and a 2 by 1, so make sure you are paying attention to that one. On 34, I understand that there were some questions on that one. Do what you can. If you do have questions about that one, come see me. On these 30 through 33, make sure you notice what the order is. So we have some of these that can work, some of them that cannot. Notice on 32 and 33, they almost look exactly the same. So they're just swapped. But notice that we're talking about a different order. So if I do this first, doesn't necessarily mean that I'll get the same thing here. Make sure you're using the matrices that they give you in the book to work on those and to figure out what those are, because you might be able to do it kind of in a proof sort way, but you might not be able to, so use what they give you in the book for your matrices for those to figure those ones out. If you do work on 30 through 33 and you don't understand how to do those ones and you do have questions about them, feel free to come talk to me if I have enough questions about them, I can go ahead and work those ones out. I might work them out anyway and put the worked out answers on the calendar just so you can see it. Those questions will not be on a quiz or on a test. I just put those on there so you can see what the properties of matrix multiplication are, because they are different. Things don't necessarily equal one and the same. So it's a little bit differently for some of those. Like I said, if you are not in class and you have questions, make sure you come talk to me. I am here before school. I am here after school. If you need to talk to me during lunch, always feel free to come talk to me during lunch. I am in the classroom 4th hour and 2nd hour, so if you need help, make sure you let me know. If you need more resources, let me know. If you were not in class today and I explain this in class, but if you are still a little confused on matrix multiplication and you look online or you look in the book, nobody really teaches you the way that I taught you. They do a thing called a dot product. Dot product is the same idea. They're just taking other numbers and setting it up a little differently. So you're doing the same exact thing. It's just called something else. When you get into higher math, if you go into physics or calculus, you'll talk about dot products a lot more for this class, because I think a lot of us maybe aren't going to do that. I wanted to steer away from the more technical part of the physics dot product situation. I just wanted to focus on figuring it out as a table. So if you have questions about anything like that, let me know and I will definitely help you. Always ask in class. Don't ever feel afraid to ask questions. I think it's a great thing when we all can figure out what's going on together. So if you have questions, let me know. And if you need me to do more problems or you need more examples, also let me know. So anyway, hope this is helpful for you guys, and hopefully I will see you in class soon.